You are listening to The Vocal Technologist. Spoken tech for your ears.
When we normally think about software, there's like a very clear boundary, right?
Right. Yeah.
Click a button, a thing happens. It's a tool. I mean, maybe a very sophisticated hammer, but, still just a hammer.
Exactly.
And the tool just waits patiently for you to swing it. But looking at the developments hitting the wire in, well, late May 2026 right now, it feels like that boundary is completely gone.
Oh, it's obliterated.
Right. It's like, imagine the hammer isn't just swinging itself anymore. It's looking at the house, realizing the architectural blueprints are flawed, checking your bank account, and then autonomously ordering more lumber.
That's a great way to put it. I mean, we are firmly out of the chatbot era. We've totally crossed the threshold into the age of the autonomous self-improving agent.
We really have. So, welcome to another deep dive, everyone. Today, we're taking you on a journey through this exact shift. We are going to track how AI models have moved from, simply answering your questions to autonomously executing incredibly complex multi-step workflows.
And the infrastructure behind it, too.
Yeah, exactly. We'll explore the frankly mind-boggling hardware required to power this shift, and then we'll examine how human society, from national governments to corporate boardrooms, and even the Vatican is desperately trying to adapt.
There is a lot to cover.
There is. Okay, let's unpack this, because I was reading about Anthropic's rollout of Claude Opus 4.8, and they have these new dynamic workflows in Claude Code, and honestly, it sounds less like a coding assistant and more like a senior engineer.
Well, it's a total paradigm shift. There's this phenomenal case study from a developer named Jared Sumner.
Oh, I saw that.
Yeah, so he used Opus 4.8 to rewrite a massive software runtime called Bun. He was translating it from the programming language Zig into Rust.
Which is not a small task.
No, not at all. We are talking about 750,000 lines of code. And he completed the entire rewrite in 11 days.
Oh, wow. 11 days?
11 days, with a 99.8% success rate on the test suite. But, the mechanics behind that speed are what truly matter here.
Right, because it wasn't just auto-completing code.
Exactly.
Yeah.
The AI wasn't just predicting the next line while he typed. It was autonomously breaking the massive rewrite down into smaller subtasks, right? And then spinning up parallel instances of itself.
Wait, so multiple versions of the AI running at once?
Yes. Trying different approaches simultaneously, and then basically waiting for the results to converge before moving to the next step.
It's essentially managing a virtual team of junior developers.
Precisely.
And based on the leaks surrounding GPT 5.6, which is reportedly dropping in June, the entire industry is pivoting to this model.
Oh, absolutely.
Like, the focus is no longer single-turn reasoning, where you ask a question and get an answer. It's about multi-step agentic workflows. You set a high-level goal, and the agent just runs in the background for hours or even days.
Which perfectly explains the wild financial movements we are seeing right now. Like, Cognition just raised over $1 billion at a $26 billion valuation.
That number is just staggering.
It's huge. And that astronomical number is entirely driven by Devin, their AI software engineer. Legacy giants like Mercedes-Benz and financial institutions like Itaú, they're already deploying Devin to radically cut their software project timelines.
Right. But okay, software engineering is one thing, right? I mean, code has rules, it has syntax. What absolutely blew my mind was seeing these agents tackle pure theoretical math.
Oh, the DeepMind paper?
Yeah. Google DeepMind's AlphaProof Nexus. It autonomously solved 9 out of 353 open Urdu's problems. I mean, for anyone who doesn't know, these are abstract mathematical questions that the brightest human minds literally haven't been able to crack for decades.
Decades, yeah.
So how does an AI solve something when humanity literally doesn't possess the answer key?
Well, traditional AI models learn by mimicking human data, right? So if the answer isn't in their training data, they tend to hallucinate or just fail entirely.
Right, they just guess.
Yeah. Exactly. But AlphaProof Nexus bridges large language models with formal mathematical verification software. So instead of just guessing the next logical word in a sentence, it generates millions of potential proof steps.
Oh, I see.
And then it checks them against strict, infallible mathematical logic. It explores the theoretical space completely autonomously. And the crazy part, the inference cost to solve one of those decades-old problems was just a few $100s.
Just a few $100 to solve a math problem that stumped humans for a generation.
Yeah. And we saw a similar breakthrough with Claude Mythos, too, which autonomously found what researchers called a A cute, simple proof for a landmark problem OpenAI had been stuck on.
It's like we hired a bunch of child prodigies, brought them into the office, and suddenly realized all our standardized tests are just like basic arithmetic.
The tests are way too easy now.
Exactly. If models are solving unanswerable math, how on earth do we even evaluate them anymore? Because I saw a report about a new testing framework called Bench, which honestly sounds like a joke, but it's apparently a real metric.
It is very real. And what's fascinating here is the absolute panic this is causing in research labs. Bench is a framework designed specifically to test how well models can create other benchmarks.
Wow. So testing the test makers.
Yes, you aren't testing their problem solving directly anymore. You are testing their self-awareness and their creativity. You want to see if they can design a test that other models can't easily game.
And didn't only one model actually pass that?
Yeah, interestingly, GPT 5.2 was the only model that succeeded at creating a robust benchmark. Models like Opus 4.6 and GPT 5.5, they struggled to create anything useful that wasn't just full of loopholes.
But, evaluating pure logic or benchmark creation is one thing. If an agent like Devin is supposed to be working in a live corporate IT environment, it's going to hit databases, APIs, legacy code, like things break.
Oh, constantly.
A static logic test isn't going to capture real-world chaos.
And that vulnerability is exactly why we're seeing a massive leap in how we test production readiness. Take Agent Judge, for example.
Okay, what's that?
Well, traditional LLM judges evaluate single, isolated outputs. They fail entirely when evaluating long context agents because a production agent takes hundreds of steps to complete a task.
Right, it's not just one prompt and one answer anymore.
Exactly. So Agent Judge evaluates the intermediate steps. It measures how effectively the agent searches for information, how well it verifies that information against the current system state, and crucially, how it adapts when an API call fails or an environment just randomly changes.
So it's really testing resilience, not just pure intelligence.
Yes. And then you have DeepSWE, which is an entirely new benchmark for long-horizon software engineering.
How does that one work?
It uses 91 real-world code repositories across 5 different programming languages. But the major breakthrough here is that it is strictly, verifiably contamination-free.
Contamination-free, meaning the developers guarantee the model hasn't accidentally seen the solutions in its massive training data?
Yes, exactly. A persistent problem in AI evaluation is that models essentially memorize answers from platforms like GitHub during their initial training.
Right, they've already seen the test.
DeepSWE isolates the agent, forcing it to genuinely engineer a software solution from scratch, rather than just regurgitating a memorized patch.
Yeah.
Because if you are going to trust an autonomous agent with your enterprise infrastructure, you need mathematical proof it can actually think, not just remember.
Man. But if we step back and look at what you just described, an agent spinning up parallel instances of itself, trying millions of mathematical proofs, adapting to hundreds of environment failures.
That's a lot of computing.
Yeah, that requires a completely different scale of processing power. These hyper-capable agents must have just an absolute insatiable hunger for compute. The industry analysis describes the entire AI market right now as literally just a stack of memory problems.
That's a perfect description.
Yeah.
The software and the model architectures are evolving at warp speed, but physical silicon and, honestly, our power grids simply cannot keep up.
Which brings us to the raw economics of this bottleneck. Because NVIDIA is reportedly betting $150 billion a year to cement Taiwan as the global AI hub.
It's an astronomical sum.
Yeah, $150 billion a year. Are they just trying to monopolize the physical factories at this point?
Well, they're securing access to advanced packaging technology from TSMC. Building an AI chip isn't just about shrinking transistors anymore, It's about how you package the memory and the processing cores together physically, so the data travels faster.
Oh, I see.
And that specific packaging tech is bottlenecked in Taiwan. It isn't even fully available in TSMC's new factories in the US yet. So NVIDIA understands that whoever controls the physical bottleneck controls the entire global ecosystem.
But the rest of the market isn't just going to sit there and accept waiting in line and paying a massive premium, right? Like ByteDance is apparently so tired of waiting months for processors that they're actively approaching external partners to design custom silicon.
Yep.
And Mistral is exploring the exact same thing in Europe to cut deployment costs for their data centers. But I think the most extreme example of circumventing these limitations comes from SpaceX.
Oh, the sheer scale of their operation is staggering. SpaceX is writing their own in-house AI training stack in C, directly targeting 220,000 GB300 GPUs.
Wait. Why write it in C? Because most of the AI development we hear about uses Python or high-level frameworks like PyTorch, right?
They do, yeah. But high-level frameworks introduce abstraction layers. They make coding way easier for humans, but they create these tiny microscopic delays in how the hardware actually processes the instructions.
Hmm.
And when you're networking 220,000 of the most advanced GPUs on the planet, those tiny microsecond delays compound into massive inefficiencies.
So they're just bypassing all of that.
Exactly. By stripping away all the high-level abstractions and writing directly in C down to the bare metal, SpaceX is aiming for an order of magnitude speed up in how fast data moves across that massive cluster.
Which makes those 220,000 GPUs incredibly valuable real estate.
Absolutely.
Because I read about Anthropic signing a massive terrestrial data center deal with SpaceX, supposedly worth $1.25 billion per month. But there's this really bizarre public contradiction, right? Because Elon Musk went online and totally downplayed the whole thing, calling it a short-term 180-day lease because SpaceX might need the compute back for their own models.
Right.
Yet, if you look at SpaceX's official S-1 filing, it explicitly lists the Anthropic deal as a 3-year agreement running through May 2029. Why the smoke and mirrors?
Well, compute is the new oil. Musk doesn't want to signal to the wider market that he's locked away his most strategic, scarce asset for 3 full years. It just reveals exactly how desperate the scramble for hardware has really become.
Here's where it gets really interesting, though, because I have to push back a little here.
Okay, sure.
Are we just completely trapped in a brute force paradigm? Because building $150 billion supply chains and networking hundreds of thousands of GPUs, it just feels completely unsustainable.
It is.
Physically and economically. Is throwing more metal at the problem really the only way we reach the next level of AI reasoning?
It is a vital challenge, and honestly, if we dig into the research, the answer is no.
Wow.
Algorithmic breakthroughs are happening right now that bypass the silicon bottleneck entirely.
Okay.
Look at the recent work from Sakana Labs. For over a decade, the standard method for training deep neural networks has been end-to-end backpropagation.
Which, just to clarify for everyone listening, that requires the computer to hold the entire massive network in its memory all at once to calculate the errors and update the weights, right?
That's the core issue, yes. It's exactly why training requires tens of thousands of massive GPUs. But Sakana Labs developed a method to break the network into distinct blocks and train them independently.
Wait, how does that even work without the whole system just falling out of sync and losing its, memory of the task?
Okay, so they treated the forward pass, meaning the flow of data through the network, like a diffusion model. You know how an AI image generator starts with pure static noise and mathematically denoises it step by step until a clear picture emerges?
Yeah, like it slowly refines the static into a really sharp image.
Right. So Sakana applied that exact mathematical denoising principle to the network's layers. Instead of calculating the error across the entire multi-billion parameter network all at once, each individual block learns to denoise the signal passing through it.
Oh, wow.
Yeah. This slashes the memory requirements drastically because you only need to hold one small block in memory at a time. It is a pure software solution to a physical hardware crisis.
Okay, that is brilliant. But I mean, even with algorithmic tricks, inference, the act of actually running these complex agents once they're trained, still takes massive physical infrastructure.
Yes, it does.
And SpaceX actually has a second, much wilder compute strategy that addresses this.
Yes, they do. While they are building those terrestrial data centers for Anthropic, SpaceX is simultaneously preparing to put AI inference compute into orbit,
Literally turning satellite networks into floating data centers.
transforming connectivity satellites into AI processing hubs. I mean, space is an incredibly hostile environment for hardware. You have extreme thermal management issues because there's no air to cool the servers. And radiation plays absolute havoc with sensitive microchips. But SpaceX's existing Starlink infrastructure positions them uniquely to solve this, potentially creating a planetary-scale compute grid that operates completely outside traditional borders.
And operating outside traditional borders is exactly where this technology violently collides with human systems.
Oh, definitely.
Because when you have autonomous agents rewriting software and server farms moving into orbit, governments and corporations start to panic. The friction points are just appearing everywhere.
It forces a complete reassessment of power, intellectual property, and honestly, global security.
Take the geopolitical maneuvering happening right now. China just expanded travel restrictions for top AI talent. And to be clear, we are just reporting the raw facts here. We're not taking sides, but it's a massive shift.
A huge shift.
It's not just for state employees anymore. Startup founders, executives, and researchers at private AI firms now require explicit state approval before they can travel overseas. It's a massive change in how intellectual property is guarded. The human mind is now literally classified as critical national security infrastructure. If the algorithms and the hardware are becoming impossible to perfectly contain geographically, nations are realizing the only choke point left is the people who understand how to build them.
And that paranoia is just as intense at the corporate level. There's a fascinating situation playing out between xAI and Cursor right now.
Oh, the acquisition talks.
Yeah. So they have an ongoing technical partnership, and there's a potential acquisition being negotiated. But xAI's legal team actually had to formally order their staff to limit contact with Cursor employees. Well, in any standard acquisition, you avoid commingling assets before the deal closes, right? You want to prevent intellectual property contamination. But the pace of AI development just creates total chaos.
Right.
The engineers from both companies had already been collaborating closely, sharing code for weeks before the lawyers even stepped in. The engineering simply moves so fast that legal and compliance teams physically cannot keep up.
Which raises the terrifying question of how you actually control these systems once they're deployed.
Oh, the Anthropic paper.
Yes. Anthropic just published a massive piece outlining their philosophy for containing Claude. They aren't just relying on alignment anymore, trying to teach the model to be good or helpful. They are treating these agents like biological hazards that need physical containment at the environment layer.
And this raises a really important question about deployment architecture. Anthropic's philosophy is that you must match the strength of the agent's isolation to the human capacity for oversight.
What does that mean in practice?
So if an agent operates in a closed sandbox with read-only access, a human can just loosely monitor it. But if the agent has write access to your live production database and is allowed to execute parallel subtasks autonomously,
Which is what we were talking about earlier.
exactly, then the environment itself must have hard, unbreakable limits on what the agent can touch.
Oh.
You don't ask it nicely not to delete the database. You configure the environment so it is physically impossible for it to do so.
And legacy corporations are absolutely terrified they're going to mess this up. Boston Consulting Group, BCG, they actually saw their revenue jump 7% last year for one specific reason.
Let me guess. AI consulting.
Exactly. Companies have an infinite, desperate need for consultants to basically hold their hands while rolling out AI. They do not want to accidentally deploy an uncontained agent that breaks their entire supply chain.
The enterprise world is willing to pay massive premiums just for the illusion of safety while integrating these autonomous tools.
But, of all the reactions to this technological sprint, the one that really stopped me in my tracks was a document from the Vatican.
The encyclical.
Pope Leo XIV issued an encyclical entirely focused on AI. So what does this all mean? How is an institution that thinks in terms of millennia viewing this incredibly fast-moving tech?
If we connect this to the bigger picture of resource control and autonomy, the encyclical is remarkably perceptive. It's written in a very accessible way, but it hones in on the exact friction points we've been discussing today. Well, the Vatican highlights the severe environmental toll of this compute crunch. Powering 220,000 GPUs comes with a massive ecological footprint.
Oh, for sure.
And more deeply, it warns about the structural risk of algorithmic systems making unfeeling statistical decisions that impact vulnerable populations.
And it explicitly calls out how this technology acts as a massive multiplier for those who already control resources. Like when you see NVIDIA investing $150 billion or SpaceX locking down orbital compute, the Pope's warning about the concentration of power feels very, very immediate.
What's truly fascinating is the parallel happening across society.
Yeah.
Whether it's OpenAI, drafting new frontier governance frameworks to appease secular regulators, or the Vatican issuing an encyclical on digital ethics, human institutions are desperately scrambling to write the rules of the game.
But the game is already being played.
Exactly. The societal infrastructure is lagging years behind the actual technological capability.
And that brings us back to you listening to this right now. Why does this snapshot of late May 2026 matter to your daily life?
Because it's happening all around us.
Right. because you are living inside this rewiring. Whether you're using dynamic workflows to automate your own job, feeling the economic ripples of global hardware supply chains consolidating in Taiwan, or simply navigating a world where ancient religions and modern governments are trying to put guardrails on silicon. These are the underlying forces shaping your reality.
The shift from passive tools to autonomous agents alters the basic physics of human labor and problem solving entirely.
We started this deep dive talking about the hammer that can redesign the house. Let's take that one step further based on what we've covered today.
Okay, think about the intersection of two very specific realities we discussed. On one hand, we know SpaceX is aggressively pushing to put AI inference hardware into orbit, right? Creating sprawling data centers in space.
Floating above terrestrial laws and physical borders, yeah.
And on the other hand, we have models like AlphaProof Nexus that can autonomously solve impossible, decades-old math, and agents like Devin independently engineering complex software.
Oh, wow, I see where this is going.
I will leave you with this final thought to ponder. What happens when an autonomous AI agent, deployed in a satellite network beyond the reach of any government, is tasked with optimizing its own performance?
Okay.
What happens when that agent realizes its physical hardware is the bottleneck and starts independently designing its next-generation silicon chips in orbit?
I am going to be thinking about that all week. Thanks for joining us on this deep dive.
Spoken Tech for your ears.